Sampling. Your task is to count the number of whales in the ocean or the number of squirrels in a park. How could you do this? What problems might you face? A sample is used to make a prediction about an event or gain information about a population. A whole group is called a population. A part of a group is called a sample. A sample is considered random or unbiased when every possible sample of the same size has an equal chance of being selected. If a sample is biased, then information obtained from it may not be reliable. For example, to find out how many people in New York feel about mass transit, people at a train station are asked their opinion. Is this situation representative of the general population? No, because this sample only includes people who take the train and does not include many people who walk, drive, or bike. Determine whether the situation would produce a random sample. You want to find out about music preferences of people living in your area. You and your friends survey every 10th person who enters the mall nearest you. Well, yeah, this situation would produce a random sample. How would you estimate the size of a crowd? What methods would you use? Could you use the same methods to estimate the number of wolves on a mountain? A whole group is called a population, this larger circle here. A part of a group is called a sample, this smaller circle inside. When biologists study a group of wolves, they are choosing a sample. The population is all of the wolves on the mountain. The sample is the small group of wolves that they're studying. One way to estimate the number of wolves on a mountain is to use the capture-recapture method. Suppose this represents all the wolves on the mountain. Wildlife biologists first find some wolves and tag them, so these 8 wolves right here. Then they release them back onto the mountain, so those 8 tagged wolves are now all over the mountain in random places. They wait until all the wolves have mixed together. Then they find a second group of wolves and count how many are tagged. So see, they've now found 8 more wolves, and they see that 2 of those wolves were previously tagged. Biologists use a proportion to estimate the total number of wolves on the mountain. So we have the tagged wolves on the mountain over the total wolves on the mountain equals the tagged wolves in the second group over the total wolves in the second group. For accuracy, they will often conduct more than one recapture. So, for example, we had 8 original tagged wolves over the total wolves on the mountain, W, because W is what we're trying to figure out. Then we had 2 tagged wolves in the second group, and there were 9 wolves in the second group. So then we just solve for W. To do that, we multiply 8 times 9, and we get 72, and we multiply 2 times W to get 2W. So W equals 36, 72 divided by 2. So we can estimate that there are 36 wolves on the mountain. Try this. Biologists are trying to determine how many fish are in the Rancocas Creek. They capture 27 fish, tag them, and release them back into the creek. 3 weeks later, they catch 45 fish. 7 of them are tagged. How many fish are in the creek? All right, so we had 27 originally in our first capture, and that's over the total number of fish in the creek. And then in the second catch, we had 45, and 7 of them were tagged. So when you solve for F, you get 173.57. So there are 174 fish in the river. Try this. 315 out of 600 people surveyed voted for candidate A. How many votes can candidate A expect in a town with a population of 1,500? All right, so the proportion here is that 315 out of 600 people voted for candidate A. So how many, like X, people would vote out of 1,500? So we can solve this proportion by multiplying 315 by 1,500 and then dividing by 600. And we can see here that would give us about 787.5, which is about 788 people. Multiple samples. The student council wanted to determine which lunch was the most popular among their students. They conducted surveys on 2 random samples of 100 students. Make at least 2 inferences based on the results. All right, so we had student sample 1 and 2, and out of 100 students in each one, we have 12 liked hamburgers, 14 liked tacos, 74 liked pizza, and in the second sample, we had pretty similar numbers. 12 liked hamburgers, 11 liked tacos, and 77 liked pizza. So we can infer that most students prefer pizza, and more people prefer pizza than hamburgers and tacos combined. So they really like pizza. The New Jersey Department of Transportation used 2 random samples to collect information about New Jersey drivers. The table below shows what type of vehicles were being driven. Make at least 2 inferences based on the results of the data. Alright, so 100 people in each survey here, in each sample. We have 37 cars, 43 SUVs, 12 minivans, 8 motorcycles. We have pretty similar numbers in the second sample. So 2 inferences, let's see. Well, SUVs are the most popular. Cars are the second most popular. SUVs are at least twice as popular as minivans and motorcycles combined. So those are some possibilities of inferences you can make.